Hello everyone, my name is Nidhi Singh. I'm assistant professor in Gyan Vihar School of Pharmacy, that is a part of the Suresh Gyan Vihar University, Jaipur. So today we are going to discuss aliphatic amine. So in this amine, in the last lectures, we have already discussed the stereochemistry, the preparation of aliphatic amines as well as the aryl amines, and we have also discussed the stereochemistry and the nomenclature and the properties of this aliphatic amines and today in this pharmaceutical, this is the fifth unit of this in this pharmaceutical organic chemistry course that comes in your B.Pharm second semester. So here we are going to discuss today the learning objectives are that there we are going to learn about amines, as well as we will study here the chemical reactions of alkyl and the aryl amine. Plus, we are also discuss some of the preparative methods or the method of preparation which are left in the last lectures. We are also going to discuss that reactions also, that methods also. And the student outcome is that they will going to know about what are amines, and they are also going to learn about the reactions method of alkyl and the aryl amine. Plus, they are also going to study about the preparation methods of this alkyl and the aryl amines, which were left in the previous lectures. So here, more method of preparations of this alkyl and aryl amines are going to come. So let's start the topic. So next method for the reaction for the preparation of this alkyl amine your is your sorry is your by Gabriel Thalamide reaction. So the Gabriel Thalamide reaction, this method is used for the preparation of primary amines. So this method is used in the preparation for the preparation of primary amines, thalamides, or reaction with ethanolic potassium hydroxide that gives potassium salt of thalamides, which on heating with alkyl halide followed by alkyne hydrolysis forms the corresponding primary amines. So here in the Gabriel Thalamide reaction, this method is used for the preparation of primary amines. So this thalamide on reaction with ethanolic. So the thalamide is going to react with the presence of ethanolic potassium hydroxide, and this potassium hydroxide um, gives the potassium salt of your thalamide, and which on heating, this on heating with alkyne halide followed by the alkyne hydrolysis, this is forming the corresponding primary amine. So in this Gabriel, this is named after the name scientist Gabriel, which first observed it, and this Gabriel Thalamide reaction, this is the method for the preparation of your primary amine. So from this method, the primary amine is prepared, and in this primary amine, the thalamide is going to react with the ethanolic solution of your this potassium hydroxide, and it is giving a potassium salt of thalamine, which on heating with alkyl halide followed by the alkyne hydrolysis gives your primary amine. So here you can see this is your thalamide structure, and when it is reacting with this ethanolic solution of KOH, that is the potassium hydroxide, then it is forming a potassium salt of thalamide. Then it is forming a potassium salt of thalamide, and after that there is the addition of alkyl halide. There is addition of alkyl halide, and from here the potassium halide is removed from this side. So here you can see this. This is your KNH. When this KOH is dissociated in K positive and OH negative, and from this the K positive and OH negative, this K will react with this nitrogen, and there is a N negative charge and the K positive charge. So there is a formation of a salt, that is a potassium salt of thalamide, and after that there is again in this reaction there is a formation of this potassium salt of thalamide. It is reacting with this RS, that is your alkyl halide, and from that alkyl halide there is a removal of this potassium halide. So this from this potassium salt, the R will get reacted with this N, and this K will removed out from here, and it will react with this halogen that is attached here. After that, there is a formation of this intermediate is formed here, which is then treated with the acid, and there is a acid plus water. There is a formation of this this carboxylic compound is formed here. So from here, OH plus one OH, that OH will react with this COH, and here OH. So here there is a formation of this carboxylic acid is formed, thus your primary amine is formed. So this Gabriel thalamide synthesis, it is a synthesis in which the in which your primary amine is formed from this thalamide, and from thalamide, firstly this thalamide is reacting with this potassium hydroxide. After that, there is a formation of an intermediate, that is your salt. Potassium salt is formed here, and this potassium salt after that is forming a intermediate, and there is a formation of, when there is acidification in this potassium salt of thalamide, there is a formation of this carboxylic acid is formed here, and the primary amine is formed here. So this primary amine can be obtained from the Gabriel thalamide reaction. Next is the aromatic primary amine cannot be prepared by this method because aryl halides do not undergo nucleophilic substitution with the anion formed by thalamide. So here the aromatic, this Gabriel thalamide reaction is for the aliphatic amines, because in case of your aromatic primary amine, this can not be prepared by this method, because in the aromatic primary amine, the aryl halides do not undergo, nucleophilic substitution. The aryl halide do not undergo nucleophilic substitution with the anion that are formed by thalamide. So this aryl halide, they are not forming, they are not undergoing nucleophilic, because in the Gabriel thalamide there is a nucleophilic substitution method reaction is happen in that. That is why they are this nucleophilic substitution method is not happening in the aryl halide. That is why they are not forming an anion reaction with the anion formed by the thalamide. Next is your By-Booth reaction. So by the Booth reaction, the primary amines can be obtained. The primary amines can be obtained by the hydrolysis of isocyanide or isocyanate. So here in the Booth reaction, the primary amines can be obtained. The primary amines can be obtained by the hydrolysis of isocyanide or isocyanate. So here by the Booth reaction, the primary amines can be obtained by the hydrolysis of isocyanide or isocyanate. So methyl isocyanide plus water, in the presence of HCl, there is a formation of this methyl amine. This methyl amine is formed, plus your formic acid is formed here. So from this Booth reaction also, there is the formation of a primary amine, and this primary amine can be obtained from this Booth reaction by the hydrolysis of isocyanide or isocyanate. So here we have taken the methyl isocyanide plus H2O, and there is a formation of this methyl amine in the presence of your HCl. Plus formic acid is also formed here. So here the reaction undergoing like this. So it needs this HCl, and this needs the H2. This needs H2. So from here, this is removed from here, and it will get reacted with this. And this, from here, the one H will be moved out, and it will react with the two H from this protons will react with this nitrogen, and there is a formation of this methyl amine. So next, in the methyl isocyanide, so this reaction is happening in the presence of your potassium hydroxide. So in this, the potassium hydroxide is reacting with this methyl isocyanate, and there is a formation of this methyl amine plus potassium carbonate. So here the potassium hydroxide is reacting with this methyl isocyanide, and there is a formation of this methyl amine plus potassium carbonate. So here you can see this is your potassium hydroxide, and it is reacting with this methyl isocyanide, and its need H2 plus K2CO3 is formed here. K2CO3 here. K2 is K2C O3. So two oxygen came from here and one oxygen is here. So this K2CO3 is formed here, and from here this two hydrogen, this two protons, these are removed from here and they are formed with this nitrogen molecule. And there is a formation of this primary amine, that is the methyl amine is formed here. Next is your by-Curtius reaction. So in the Curtius reaction, what is happening, that the acid chloride on reaction with sodium azide give isocyanide, which is decomposed with water into amine. So in this case, the acid chloride reacting with the sodium azides, and there is a formation of this acyl azide, and this is heated, and after that there is a formation of this isocyanide, and isocyanide is reacting with this nitrogen, and there is a formation of this methyl amine. This methyl amine is formed here, and the carbonate ion is formed here. So this is the Curtius reaction. So in this Curtius reaction, what is happening, this is the acid chloride. So this acid chloride is forming a reaction with this sodium azide. So there is a formation of this three nitrogens are get connected to this, bonded with this carbon. So this carbon is reacted with this three nitrogen, and there is a removal of this NaCl. So this NaCl is removed out from here, and this NO3 is attached to this carbon atom, and this there is a formation of this acyl azide, and this when this acyl azide is heated, then there is a removal of the nitrogen from here. So from this nitrogen gas is revolved out from here. After that, this there is a formation of the isocyanate. So there is a formation of this isocyanate, and this isocyanate is reacted with this basic and this base, and there is a formation of this primary amine, and the carbonate ions are formed here. So this is a Curtius reaction, and this Curtius reaction, this is the acid chloride, and this and the from the acid chloride, the primary amine is formed. So these in the last two reaction, the Gabriel phthalate reaction, in this reaction also the primary amine is formed. So primary amine is firstly formed from this phthalimide, and this phthalimide is firstly reacted with the potassium hydroxide, that is the ethanolic solution. Means in this the ethanol is also added. So this is a ethanolic solution of this potassium hydroxide, and this is giving a potassium salt. So there is a formation of this potassium salt of phthalimide. So this potassium salt of phthalimide is reacted with the alkyl halide, and from here the potassium halide is removed out from here, and from this there is the formation of this intermediate is formed here, and which is then acidified, and there is a formation of the carboxylic acid. Carboxylic acid is formed here, plus your primary amine is formed there. So so by the Gabriel phthalate reaction, the primary amine, which is the aliphatic amine, is formed from this phthalimide, and from this phthalimide, and in this reaction, from this reaction, the acyl aromatic amines are not formed, because aromatic amines does not undergo nucleophilic substitution reaction. So in this, and there is a no formation of the ions also are not formed here. That is why the primary amines are not formed in this. Primary amines are formed from the phthalimide, and by the following steps they are formed, and this method is used for the preparation of primary amines and phthalimides. On reaction with ethanolic potassium hydroxide, we are giving the potassium salt of phthalimide, and this potassium salt of phthalimide on reaction on heating with the alkyl halides, followed by the alkyne hydrolysis, they are forming a corresponding primary amine, and this the aromatic amines are not prepared by this method, because the aryl halides from aryl halides do not undergo nucleophilic substitution reaction with the anion formed by phthalimide. So here the aryl halides. So here the aliphatic halides are attached, alkyl halides. So this aryl halides are not undergoing the nucleophilic addition reaction. They are not giving any nucleophilic addition reaction to nucleophilic substitution reaction, sorry, and with the anion, and these are formed by phthalimide. So by the Woods reaction, this primary amine, These primary amines can be obtained, or these can also obtained by the hydrolysis of isocyanide or isocyanide. So from Woods reaction, the primary amine is formed, and from the methyl isocyanide also this primary amine is formed, and from the methyl isocyanide also from this methyl amine is formed, and this whole reaction is known as Woods reaction. So in this Woods reaction, you can see that the methyl isocyanide is reacting with the water molecule in the presence of your HCl, and it is giving, or it is forming here methyl amine plus formic acid is formed here. Next, by the methyl isocyanide, which is reacting with the potassium hydroxide, that is the alkali. So here that is forming a methyl amine. So plus potassium carbonate is also formed here. So this whole reaction is your Woods reaction. In the Woods reaction, there is the hydrolysis of the isocyanide, and the isocyanides occur, and from this there is the formation of the primary amines is occurred from here. Next is the Curtius reaction. So in the Curtius reaction, the acid chlorides are reacted with the sodium nitrite from the sodium azide, and the acid chloride from the sodium azide. This chlorine is removed out from here, and from the sodium azide, the sodium uh, 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 removed out from here, and then they both of them, this chlorine and sodium, will form a bond, that is the NaCl is formed here. After that, in the acid chloride, this acid chloride is converted into the acyl azide, and this acyl azide is heated. This acyl azide is heated, and there is the formation of this isocyanide. So this isocyanide is formed here. Thus the nitrogen gas is removed out from here, and after that there is the formation of this isocyanide, and from this isocyanide, which is reacted with this base, and there is the formation of this primary amine, the carbonic ion is released out. So here in the previous reaction, in the Woods reaction also, you can see that this isocyanide is reacting with KOH, that is the base, and there is the formation of methylamine. So here also the isocyanide is formed, and this isocyanide is reacting with this base, this KOH, and there is a formation of this OH negative, and there is a formation of this primary amine. The next is the Lawson reaction. So in the Lawson reaction, the Lawson rearrangement is the conversion of hydroxylic acid to isocyanide through the formation of O-ethyl sulfonyl or phosphoryl intermediate hydroxylic acid O derivative, and this rearrangement is used for the synthesis of your secondary amine from hydroxylic acid. So in the Lawson reaction, synthesis of primary amine from this Lawson from hydroxylic acid. So this is the Lawson reaction. So this is a conversion of hydroxylic acid to the methyl primary amine. So here you can see that in the Lawson rearrangement, this is a conversion of a hydroxylic acid to isocyanide. Firstly, there is the formation of this isocyanide, and then the isocyanide will react with the base, and there is a formation, that is the OH negative, and there is a formation of a primary amine. So, and this rearrangement, in this there is a formation of the O-ethyl sulfonyl or phosphoryl intermediate is formed in this intermediate hydroxylic acid O derivative is formed here, and this rearrangement is used for the synthesis of primary amines from hydroxylic acid. So here you can see this is a hydroxylic acid, and it is reacting with this OH negative, and there is a formation of this intermediate is formed here, and this intermediate, from this intermediate, it is forming alkyl isocyanide. So this alkyl isocyanide is formed, which is then reacted with the water molecule, and there is a formation of the primary amine. There is a formation of a primary amine plus CO2 is evolved out. So in this case, there is the evolution of the CO2 occurs. So this is the Lawson reaction. So in the Lawson reaction, primary amines are formed. This is the method of 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 your primary amines from the hydroxylic acid. There is, there is also a formation of this OSIL sulfonyl or the phosphoryl intermediate hydroxylic acid co-derivative is also formed in this reaction, and from this the hydroxylic acid there is a formation. Firstly, there is a formation of alkyl isocyanide, and this alkyl cyanide, from this alkyl isocyanide there is a formation of a primary amine. So this is also a method for the preparation of the primary amine. This Lawson reaction is also a method for the preparation of the primary amine. Next is your additional method for the preparation of secondary amine. So the additional method that are used for the preparation of your secondary amine, that is your by the reduction of alkyl isocyanide or the isocyanide. So from the reduction that is happening in this isocyanide and the isocyanide, from that methods the secondary amines are formed here. So the isocyanide or isocyanides are reduced to secondary amines with the hydrogen gas in presence of sodium C2H5OH and R and C plus 2H2. There is a formation. This alkyl isocyanide is formed from in this alkyl isocyanide. There is a reduction that is occurring from the hydrogen is adding to this alkyl isocyanide in the presence of sodium or ethyl alcohol, and there is a formation of this methyl alkyl amine. So there is a formation of this methyl alkyl amine, and this CH3 and C plus H2, this your methyl cyanide, methyl isocyanide, and from your methyl isocyanide, there is a reduction is happening in this methyl isocyanide in the presence of the sodium or your ethanol, and there is a formation of this secondary amine, methyl with dimethyl amine is formed here. So in this, the dimethyl amine is formed in this method. So this is the first method. In the additional method for the preparation of your secondary amine, the first method for the preparation of the secondary amine is your first is your or by the reduction of alkyl isocyanide or the isocyanate, and in this the isocyanate or the isocyanides are reduced to secondary amine with hydrogen gas in the presence of sodium and C2 ethanol. So next is your by the reduction of N-substituted amine. So here the amides, from the amides, in the amides there is a reduction that is happening, and from this reduction there is a formation of this secondary amine is formed here. So by the reduction of N-substituted amides, the secondary amides can be reduced to amines by the strong oxidizing agents like lithium aluminium hydroxide, by the conversion of carbonyl group to the CH2. By amides cannot be replaced by the less reactive sodium bromohydride. So here in the reduction of N-substituted amide, the secondary amides, these secondary amides can be reduced to amines by a strong oxidizing agent. So here the secondary amides can be reduced. The secondary amides are reduced to the secondary amines in the presence of a strong oxidizing agent. So here there is a presence of a strong oxidizing agent like your lithium aluminium hydroxide, and there is a conversion of carbonyl group to this CH2 group, and the amides cannot be reduced. The amides cannot be reduced by this less reactive sodium bromohydride. That is why there we have used the lithium aluminium hydroxide, lithium aluminium hydroxide, lithium aluminium hydride. So from this, the secondary amides are reacting, and they are reacting in the presence of the catalyst, that is your lithium aluminium hydride, and then the formation of the secondary amine, that is methyl amine is formed from the N-methyl acetamide, and there a strong oxidizing agent, that is your lithium aluminium hydride, is used in spite of your instead of your sodium bromo hydride, because these are less reactive and they cannot be this these N-methyl are not reduced or not reduced by these catalyst that is your sodium bromohydride. So in this, by the reduction of N-substituted amide, the secondary amides can be reduced to amines by a strong oxidizing agent like lithium aluminum hydroxide by the conversion of your carbonyl group to the secondary amine, and this amide cannot be reduced by the less reactive sodium bromide. So here you can see that there is a conversion from CO to CH2. So here in the N-methyl acetamide, there is CO is present in between. So this CO is converted to this CH2. That is why there is a formation of this secondary amine. So this is the ethyl methyl amine. So by heating phenol with alanine, so here we are heating the in the third reaction, we are heating the phenol with aniline and there is the formation of the secondary amine. So here there is the formation of the secondary amine. So in this we are heating the phenol with the aniline and the secondary amine. Aromatic amines are prepared by heating phenol with aniline in presence of anhydrous zinc chloride at 200 degrees centigrade. So here, the phenol is reacting with this aniline, is heated with this aniline in the presence of the zinc chloride, in the presence of the zinc chloride at 200 degrees centigrade, and there is a formation of this diphenylamine. So there is a formation of this diphenylamine. So here, the secondary aromatic amines are prepared by heating phenol. So here, this phenol is the aromatic compound, and this aniline is also an aromatic amine. And when both of them are reacting in the presence of a catalyst, that is your anhydrous zinc chloride, in the presence of 200 degrees centigrade, in the presence of 200 degrees centigrade, that is a very high temperature. And this high temperature, there is a formation of this secondary amine, that is your diphenylamine. So from there, this H2O is removed out. So here, if there is a formation of diphenylamine, then this OH and this H will be moved out from here, and there is a formation of this is diphenylamine. So this H from here and OH from here will move out. There is a formation of NH2, and this NH2 is bonded to this phenyl group. So there is a formation of this diphenylamine. Next is by the addition method for the preparation of tertiary amine. So in this case, by the reduction of N-N-di substituted amides. So here the reduction of N-N-di substituted amine, the N-N-di substituted amine yield tertiary amines on reduction by lithium aluminum hydride. So here in case of N-N-di methyl propanamide is reacted with this lithium aluminum hydride, there is the formation of this N-dimethyl propanamide. So by the reduction, so here the N-di substituted amines are reduced, and there is a formation of this dimethyl propanamide, which is a tertiary amine. So this tertiary amine is formed in the presence of a catalyst, that is the lithium aluminum hydride, and plus the hydronium ion, this N-dimethyl propanamide. Here you can see this is the propanamide, and there is a conversion of the CO carbonyl group. The carbonyl group is converted to the CH2 group. So here also the reduction is happening here. So in the presence of the reduction, there is a formation of a tertiary amine is occurring here, and this tertiary amine is formed from the amides. So from the amides are converting into the amines. So from the amides, that is your CO NH2, that is converted into the CH2N, and all the three nitrogen on the nitrogen there is a replace, there is all the three alkyl groups are present. So this its name is N-dimethyl because of the N2 dimethyl are present, and propanamide. Next is your from the Grignard reagent. So from the Grignard reagent, the Grignard reagent can be used to synthesize tertiary amine as follows. So firstly, the Grignard reagent is formed from the reaction of alkyl halide with the magnesium, and the magnesium then reacted with alkyl halide, and there is a formation of the Grignard reagent, that is RGMX, RMGX. So this RGMX, MGX, in this X is the halogen, I is the alkyl. So the alkyl, uh, here we have taken the chlorine. So here the RMGX, the alkyl magnesium chloride, plus uh, this secondary amine is formed here, and from this secondary amine, this chlorine and two alkyl groups are attached here, and from that the tertiary amine is formed here, and this tertiary amine is formed here, and MgCl2 is formed here. So the tertiary amine is formed from this secondary amine by the Grignard reaction, and there is a formation, or there is a synthesis of this tertiary amine. So here CH3 is our Grignard reagent, and from this is reacting with the CH3 and CH3, and there is a formation of this tertiary amine. So this tertiary amine is formed here, plus MgCl2 is formed here. So MgCl2 is formed here from this Grignard reagent, and there is a formation of this tertiary amine is formed from this Grignard reagent. So this is a preparation of. So here from the preparation, this method of the preparation of tertiary amine, there are two methods: by the reduction of NN disubstituted amides, and from the Grignard reagent. From these two methods, the tertiary amines are prepared. The next is your by the decomposition of tetra-alkyl ammonium hydroxide. So from the decomposition of this tetra-alkyl ammonium hydroxide, this cautionary ammonium salt is hydrolyzed. The cautionary ammonium salt is hydrolyzed with moist silver oxide with uh, ammonium, ammonium hydroxide, which on heating gives tertiary amine. So this from this tetra-alkyl aluminum hydride, when this tetra-alkyl ammonium hydroxide is decomposed, then there is a formation of a tertiary amine. So in this reaction, you can see there is a decomposition of tetra-alkyl ammonium hydroxide, and the quaternary ammonium salt is hydrolyzed with moist silver oxide with quaternary ammonium hydroxide, which on strong heating, gives tertiary amine. So this is your tetraethyl ammonium iodide, and this tetraethyl ammonium iodide is reacted with this silver hydroxide, and from this silver hydroxide, tetraethyl ammonium hydroxide is formed here, plus silver iodide is formed here, heating, and then after heating we are getting here triethylamine is plus ethene is formed here, plus your water molecule is formed here. So from the trialkylamine is formed from this tetraalkyl ammonium hydroxide. So here, so from here, this this trialkyl amine is formed from. Sorry, this tertiary amine is formed from this tetraalkyl ammonium hydroxide. From this decomposition, from the conversion from the hydrolysis of tetraalkyl ammonium hydroxide to tertiary amine is formed. Next is your by the Ullmann reaction. So in the Ullmann reaction, the tertiary aromatic amines are obtained by heating diphenylamine with iodobenzene, potassium carbonate, and a small amount of copper as catalyst in nitrobenzene solution. So this is an Ullmann reaction, and in this, this triamine is formed here, and the tertiary amine is formed here. So the tertiary aromatic amine can be obtained by heating diphenylamine in with iodobenzene with the potassium carbonate and a small amount of copper as catalyst in nitrobenzene. So this diphenylamine plus iodobenzene plus K2CO3, that is your potassium carbonate, that is in the presence of copper, it is formed, and there is a formation of this triphenylamine is formed, plus potassium iodide is formed, plus CO2 that is evolved out, carbon dioxide gas is evolved out from here, plus water molecule is formed here. So this is the fourth reaction of the tertiary amine, from where the tertiary amines are formed here. So in this, there is a tertiary amine can be obtained from the diphenyl amine, that is your secondary amine, that is your secondary amine plus your secondary amine plus your idobenzene. So here in the idobenzene plus your or so from this, the tertiary amine are obtained by heating the diphenyl amine, that is your secondary amine, with the idobenzene plus your potassium carbonate plus your small amount of copper, and there is a formation of this tertiary amine plus potassium iodide plus CO2 is formed here. The next is your reductive amination of aldehydes and ketonic compounds. So aldehyde and ketones can be converted into primary, secondary, and tertiary amine using reductive amination in presence of ammonia or amine. So in this, the aldehydes and ketone, that are the carbonyl compound, they can be converted into the primary, secondary, and the tertiary amine using a reductive amination in the presence of ammonia or amine, and the reaction is completed in two steps. So this reaction of this aldehyde and ketone, they are converted into, this reaction is converted and formed in the two steps in the presence of ammonia and amine or amine. The reaction is the first step is the nucleophilic addition of the carbonyl group to form an imine. So in the first step, from this carbonyl compound, there is a ammonia is added and there is a formation of this imine is formed here. And in the second step, there is a reduction. There is a reduction of the imine to an amine using a reducing agent. So this from the imine is reduced in the presence of the hydrogen. There is a reduction that is occurring in this second step, and from here the imine is converted to the amine, and a reducing agent employed commonly includes hydrogen, and a catalyst such as your nickel, sodium NaBH3CN, that is the sodium cyanobromohydride, and lithium cyanobromohydride, etc., and the general reductive reaction of aldehyde and ketone are formed. So in this, the carbonyl compound is converting into the amines and primary, secondary, and tertiary amines in the presence of your ammonia and using the reductive amination in presence of ammonia or the amines, and the reaction that is occurring in the two steps. In the first step, there is a nucleophilic addition. There is a step in the first step. There is a nucleophilic addition of the carbonyl compound, and there is a formation of this imine. So here you can see in the reaction, when this ammonia is added in the carbonyl compound, there is a formation of imine. And after that, in the second reaction, in the second step, there is a amination. There is a reduction of this imine to an amine using a catalyst, and a reducing agent employed commonly includes. So the reducing agent that are included in this are the hydrogen, a catalyst, that is your sodium cyanobromohydride or the lithium cyanobromohydride, etc. And the reductive reaction is as follows. So in this reaction, you can see here that this is the carbonyl compound, and in this the nitrogen is added, ammonia is added, and there is a formation of this imine. So this is the first step of this reaction. And in the second step, this formed imine, this is reduced in the presence of hydrogen and a catalyst, and there is a formation of amine is formed. Next is the conversion of an aldehyde or ketone into primary amine. So this is the aldehyde, and when it is reacting in the presence of a sodium ammonium and the sodium cyanobromohydride, there is a formation of a primary amine. So there is a formation of this primary amine from the carbonyl compound, and in the presence of this ammonia, and the sodium bromohydride, cyanobromohydride. For example, methyl ethyl ketone. Here we have taken the example, that is your methyl ethyl ketone, and this reduced in the presence of hydrogen, ammonia, and the nickel. And there is a formation of this 2-aminobutane, which is a primary alkane. Primary amine. So here the primary amine is formed in the presence of ammonia as well as the nickel and the hydrogen, and there is a presence, there is a from this ketone, this methyl ethyl ketone. From this methyl ethyl ketone, this is formed. This 2-aminobutane is formed here. Next is your similarly benzaldehyde. Similarly, benzaldehyde is reduced with ammonia. Similarly, benzaldehyde is reduced with ammonia in presence of hydrogen and nickel into benzyl amine. So here benzaldehyde is reduced with ammonia in presence of hydrogen and nickel into benzyl amine. So here benzaldehyde is reacting is reacting to this benzyl amine, and benzaldehyde is reacting in the presence of this hydrogen, ammonia, and the nickel, and there is the formation of this benzyl amine. And here the conversion of aldehyde or ketone into secondary amine. So here this is your aldehyde, and this there is a this aldehyde is reacting in the presence of the ammonia and sodium cyanobrommohydride, and there is a formation of this secondary amine is formed here. So there is a formation of the secondary amine is formed in this process, and there is a conversion, of this aldehyde or ketone into tertiary amine. So here again in the aldehyde or ketone, from this aldehyde, this sodium cyanobrommohydride, and there is a formation in the presence of this secondary amine, there is a formation of this tertiary amine. So from this second tertiary amine, there is a formation of this tertiary amine. So here from the carbonyl compound, this carbonyl compound can be converted into the primary, secondary, and tertiary in the presence of ammonia, plus in the presence of amines also. So in the first reaction, you can see the benzaldehyde is there, and this carbonyl compound is converted into the primary amine in the presence of ammonia. Next, in this, the aldehyde or ketone is converting into the secondary amine in the presence of your primary amine plus your sodium cyanobrommohydride. And in the third, the conversion of aldehyde or ketone into tertiary amine, this aldehyde or ketone, in this the sodium bromohydride. This is sodium in the presence of the sodium cyanobrommohydride. This is converted in the tertiary amine in the presence of secondary amine. So this is your conversion from the aldehyde, and this is the mechanism. From this mechanism, the sequential mechanism is as follows: the aldehyde of ketone in the primary amine. So these electrons are getting reacted with this, and there is a formation of this hemiaminal. So this hemiaminal is formed here. Then this imine and this hemiaminal are both are reduced, and there is a formation of this secondary amine. So this is a two-step reaction. In the two-step reaction, in the first reaction, this carbonyl compound is reacted with the ammonia, this primary amine, and from this primary amine, the CO is moved off from the CO is having the withdrawing the electron from this carbon, and carbon is having the positive charge, and O is having the negative charge. Next, from this, the hydrogen is moved out from here, and this hydrogen is getting attached. This hydrogen is moved as H positive. And this H positive is reacted with this O negative, and there is a formation of this OH group. Plus this NHR is then formed, is having a negative charge, and then it is reacted with this carbon molecule, and there is a formation of this hemiaminal is formed here. So this hemiaminal is then reacted with this imine, and there is a formation of the secondary amine. So the important reaction of this amine is that reaction of aliphatic amine. There is a primary amine, and when this HCl is added to this, there is a formation of the CH3, CH2Cl, and when there is a alkyl bromide is reacted, then there is a formation of this secondary amine, and the secondary amine, when there is a addition of this alkyl halide again, then there is a formation of this tertiary amine, and from this tertiary amine, there is addition of this alkyl halide, then there is a formation of partially ammonium salt. Next, when there is a primary amine, there is a reaction with this acetamide, and there is a formation of this N-ethyl acetamide is formed here. Next is this is forming with the this SO2Cl. There is a sulfonamide, so there is a formation. Sorry, this benzene sulfuric chloride. Then there is a formation of this N-ethyl benzene sulfonamide. Plus after that, this is in this sodium hydroxide is added, and there is a formation of this salt. These are the few reactions that are happening, and then this HNO2 nitrous acid. There is a formation of alcohol plus nitrogen gas is evolved out. These are the reactions of this chemical reactions of this ammonia amines. So here this amine, this primary amine is reacted with this aldehyde, and there is a formation of this aldeamine. And this carbon disulfide, there is a formation of this dithiocarbon carbamic acid, and in the presence of mercury chloride, there is a formation of ethyl isothiocyanide. It is formed. So in this, the HOCl, there is a formation of this N-chloroethylamine, and there is a formation of N-dichloroethylamine. Next, these are the reaction of aromatic amines. So this aniline is reacted with this HCl. There is a formation of this aniline chloride, and there is a formation of benzene diazonium chloride. So these are the few reactions that are of aromatic amine. Reaction of aromatic amine, which is involving the benzene. And this is the meta nitroamines, and there is a formation of these products. These are giving the dyes. These are the questions. So which function group is present in a function primary amine? That is your NH2. Which one of the following is an amino compound? That is your CH3, CH2NO, this CH3, NH, C2H5, that is the B. All three amines can be obtained from by the reductive amination of aldehyde and ketone. Amines are weak bases due to the presence of unshared pair of electron or nitrogen atom. Chloramine react with methyl magnesium chloride to form methylamine. Partially ammonium salt on hydrolysis, which most silver produces, a tertiary amine. And these are the references from where you can study this topic. And thank you so much for today's lecture.